Hi, welcome to this video on the zero exponent rule. In class, we started by students typing numbers into the calculator and raising them to a power of zero, and they quickly discovered they got the answer of 1 every time, except for if you do 0 to the 0, that is undefined in mathematics, and we'll explain why in a minute. Let's do a little example to understand why something raised to a 0 power is equal to 1. So one way to do this problem is to use your quotient rule, where you take the top power and subtract the bottom power. So we're doing 3 minus 3 because we're canceling them out. And you get 2 to the 0 that way when you subtract the exponents with the quotient rule. Another way to look at it is maybe to expand the exponent and do actual division to see what you get. 2 times 2 times 2 is 8, and also 8 on the bottom. And anything divided by itself is equal to 1, which is why when you cancel common factors, 1 times 1 times 1 gives you 1 anyway. So if 2 to the 0 is equal to 1, if 2 to the 0 is equal to 2 to the third over 2 to the third, and 1 is also equal to 2 to the third over 2 to the third, then that means that these two things, by being transitive, if they're both equal to the same thing, they have to be equal to each other. And you can do this with any base and any power, and the same result will happen. However, I said I would come back and explain why 0 to the 0 is undefined. If you try to do this with 0 as a base, it's not going to work. Like, for example, 0 squared over 0 squared. 0 times 0 is 0. 0 times 0 is 0. But in math, you are not allowed to divide objects into groups of 0. It is impossible to do. Cannot divide by 0. That is why if in a calculator you type in 0 to the 0 power, it will tell you there's some kind of error because you cannot do that. So I want you to remember the following. Even though, yes, the 0 exponent is very easy to understand, that anything to a 0 power is 1, it doesn't mean that whenever there's a problem with a 0 exponent, the answer is going to be 1. It's only the bases that are raised to the 0 power that can be replaced with a 1. So this first example is the simplest one. 5 to the 0 is 1. The second example is also simple. We have a negative in a power or in a base, but the whole expression is raised to the power of 0, so the answer is 1. But on number 3, we have to follow the order of operations. Exponents come before subtraction here. So this says negative of 7 to the 0, and 7 to the 0 is 1, so the answer is negative 1 for that one. In number 4, 17 has a power of 1, so it is 17. But m to the 0 equals 1, and 17 times 1 is 17. On number 8, 8 to the 0 is 1. 8 squared is 8 squared, or 64. So 1 times 8 squared would be 8 squared, or you could evaluate and say 64. Another way to look at this is you can use your rule for multiplication that says you add the exponents. You would still get a 2. 0 plus 2 is 2, so you would still get the same answer. So on number 6, we have 6 times x to the 0, which is going to be 6 times 1, plus 8 times y to the 0, which is 8 times 1. So 6 times 1 is 6, 8 times 1 is 8, so the answer is 14. Number 7, we have 8 times 1 plus 1, because k to the 0 is 1. We have to remember, on these little numbers that don't have powers, the powers are understood to be a 1. So we have 8 plus 1, which is 9. C to the 0 is 1. 4 to the 0 is 1, and 1 plus 1 is 2. So these are the kinds of problems that you will be dealing with 0 exponents on. The worksheet for today is going to include some of these, but also include previous exponent rules. Let's look at some negative and 0 exponents in another way. All right, I'm going to evaluate these and put them in simplest rational form. So 2 to the fourth is 16. 2 to the third is 8. 2 to the second is 4. If we look going back down the chart and the other way, we can take each number and divide by 2 to get the previous number. 16 divided by 2 gives us 8. 8 divided by 2 gives us 4. So I'm just going to keep dividing by 2. We get 2. If I divide by 2 again, we get 1. Look, here's our zero exponent rule right here. 2 to the 0 is 1. But I want you to understand that we can just keep dividing by 2 to get previous answers. If I do 1 divided by 2, I get 1/2. There's our negative exponent rule. We can see that it's moving it to the denominator, our negative exponent rule, because of this pattern of continually dividing by 2. Divide by 2, 1/2 divided by 2 is basically like, it's 1/2. If you divide by 2, it's the same as timesing by a half. We get 1/4. If I take 1/4 and divide it by 2, that's the same as multiplying it by 1/2. I get 1/8, which we can see as 1 over 2 to the third, 1 over 2 squared. So we can see it bumping that exponent over to the denominator. 1/8 divided by 2 is the same as times 1/2. We get 1/16, which is the same as 1 over 2 to the fourth. So in all of these, we can see that negative exponent rule playing out here. So I'm just going to highlight these as being the negative exponent rule. Hope I don't delete all this. Just coloring it all in because all the green ones are showing us the negative exponent rule. And the yellow one is showing us the zero exponent rule right here. So at the bottom, it says this chart shows two rules, the zero exponent rule and our negative exponent when it's in a numerator rule. That x to the negative a, we move it to the denominator and make it 1 over x to the a. You can see that right here, 2 to the negative fourth, 1 over 2 to the fourth, or 1 over 16. Zero exponent rule, x to the 0 equals 1. You can see that here in that 2 to the 0 is 1. So that's our lesson on zero exponents. Join us next time where we will talk about the power to a power rule.